children, welcome back to the Max class, Easy Conceptual Learning by Saujanya. Yes, so in the previous video we have learned about the closure property and commutative property, and now we have come to another property called associative. Before going into today's video, let us once recall all that closure and commutative property. Closure property, what do you mean by, what is the property? Can you recollect that? Yes, if we are having two integers, say suppose A or B, A and B together, then A plus B is equal to an integer. A plus B is equals to an integer. That means when you add two integers, even A and B are also an integers only. When you add them, you should get the answer as an integer. If you get the answer like that, it means that the given sum or is satisfied under the closure property, under addition, under one arithmetic operation. Even the subtraction is also of the same kind. A minus B is equals to an integer. Okay, so under two arithmetic operations, we have seen the closure property. A plus B is equals to integer and A minus B is equals to integer. Okay, so if you get an integer, then it is satisfied under both either addition or subtraction, whatever it is given for you. Yes, now let us recall the commutative property. Commutative property is nothing but A plus B is equals to B plus A. A plus B is equals to B plus A. That means what? When you add two integers, you'll be getting an answer. Where if you add the two integers even in the reverse order, in the vice versa process also, you should get the same answer. Then only commutative property is satisfied under the given arithmetic operation. That is whether it is addition or subtraction. Okay, but I have explained you in very clearly that commutative property satisfies only addition for integers. It will not be satisfied under subtraction. Why? Because when you subtract, you won't get the same answer. But that means A minus B will never be equal to B minus A. Okay. So this is what we have concluded in the last video, that closure property means A plus B is equals to an integer under addition and A minus B is equals to an integer under subtraction. And commutative property, A plus B is equals to B plus A. Okay, and it is satisfied only under addition and it is not satisfied under subtraction. Yes, yes. So however, we have recalled both the things. Now let us go back into the associative property. Here, associative property will have three integers. That means it has a usage of three integers in the property. That is, if you have A, B and C, three integers. We have to use three integers in order to know whether the associative property is satisfied or not. So these three integers are nothing but A, B and C. We are just supposing. Means you are taking, instead of A, B and C, some integer. If you take some integer, the condition to be satisfied is A plus B plus C is equals to A plus B plus C. Okay, so you may wonder, both the sides are all equal. Only the difference is they are having the brackets different. Yes or no? So even in that brackets different also, sometimes you may not succeed according to the integers. But if these both are satisfied according to the BODMAS rule, which you have learnt in your 6th. So you all have heard about the BODMAS rule, where we will be first simplifying the brackets. Yes or no? So first simplify the brackets and then go to the other number which is there. Here also first simplify the brackets and then go to the other number. Okay. So if you get both of them equal, that means if you get both the sides, LHS is equals to RHS, the value, under any condition, if you take A, B, C as integers, then it is said that associative property is satisfied under addition. Associative property is satisfied under addition. Yes. So subtraction part actually is not at all included for associative property for class 7. So what are the concepts which are hidden from your textbook? We will go according to the textbook. Okay. So A plus B plus C is equals to A plus B plus C. Okay. So now associative property. How can you know that the given integers satisfy associative property? Let us take one example and solve it. See, suppose we are taking A is equals to 5. A is equals to 5. And A is equals to 5 and B is equals to 4. C is equals to 3. See, 3 integers I have taken positive only. But integers in the sense, it doesn't mean that I have already told you during the definition that integers means not only positive numbers but also positive, negative numbers and included with the 0. Okay, so see these. Let us see the condition for LHS. The left hand side 5 plus substitute. That means write instead of. Substituting means writing instead of. Instead of A you write this value. Instead of B you write that value. 4 plus 3. Okay. Now see. 4 plus 3. First you should not write 5 plus. Whenever you see something inside the bracket, what you have to do is, if your simplification is more than 1 or 2, if it is 1 you usually do that only. But if it is more than one arithmetic operation is given, then what you should do is you will follow the BODMAS rule. Okay, BODMAS rule, which has been taught for you in class 6, which means that the brackets of division, multiplication, addition and subtraction, it tells you the sequence. That means which arithmetic operation should be followed first, next which one and next which one. Okay, they are given in an order: division first, then multiplication, then addition and then subtraction. So you can ask me, we don't have division here, we don't have multiplication here, why should we follow it? Because the first preference is given for bracket. That means any arithmetic operations, out of 4 arithmetic operations, any of them which are there inside the bracket should be solved first, irrespective of the arithmetic operations in the order. Now see, 4 plus 3 is 7. 7 plus 5. So this becomes 12 here. Yes or no? This becomes 12 here for left hand side. Now take right hand side. When you take right hand side, 5 plus 4 plus 3. Is this the order? Yes. So 5 plus 4 is 9. 9 plus 3 is how much? 12. So that means, therefore, A plus B plus C is equals to A plus B plus C. That means here for the given integers where A, B, C values are given, associative property is satisfied under addition. So I hope you understood this, as we have given one example here. Okay, so remember that there are conditions for all the 3 properties which are given conditions, so that if the condition is satisfied only, the property is said to be there, satisfied there in a certain example. Okay. Now, after this associative property, actually associative property under addition is explained elaborately, and after that we had some other new topics like finding out identities and all. But actually the very next topic of this is additive identity. What is it? Additive identity. What do you mean by additive identity? Additive identity is nothing but if you add, that means if we add any whole number to a 0, what is the answer what we get? Yes, 5 plus 0. Yes. In the similar manner, additive identity. Okay, if we add any number, any whole number to the 0, what will happen? You get the same answer. Yes or no? You get the same answer. Yes. Will you get any different answer? Yes. You may wonder why this whole number came. Actually, for additive identity, if you add any whole integer, but first I want you to understand what is a whole number, and then I want to come to whole integer. Whole numbers means, you know, we have already defined in the previous thing, like you have to know all the numbers types. Whole number means a set of whole numbers is 0 plus the positive numbers. We call them as a whole numbers. What are the whole integers? Whole integers are in the sense all the integers, that means negative numbers, positive numbers as well as 0. Okay, so if any whole integer is added. Now I added a whole number. Now let me add one negative number. Minus 4 plus 0 is equals to, it becomes minus 4 along with its sign, children. Don't forget the sign. When you add 0 to any integer, it can be anything like any positive number or any negative number. If you add it with the 0, you get the same number. Okay, this kind of getting out the same number as its sum, we call it as additive identity. And so what is the additive identity of all the integers? Yes, so 0. Can you tell that, suppose if there is any whole number or any whole integer plus you add any other number, will you get the same integer which you are adding? No. But when you add 0 to that, what is happening? You are getting the same answer for that. Yes or no? The same integer is being repeated as the answer. So 0 becomes the additive identity of all the integers. 0 is the additive identity of all the integers. So I hope you understood this concept also. Additive identity is nothing but if you add 0 to any whole integer or to any integer. So if you are confused with the term of whole integers, you can just tell if you add it to any integer, because I cannot tell you integers. Integers, you should not add 0 to that. Okay, so if you add 0 to any of the positive or negative integers, what is happening? The result obtained is the same as the integer we are adding. So you get the same integer. So that is why 0 is called as a additive identity of all the integers. Hope you all understood both the terms today we have used. Associative property, a plus b plus c is equals to a plus b plus c. So use the BODMAS rule whenever you're going for simplification. Okay, and regarding subtraction, we are having only till addition, where you can use the further arithmetic operations in the next upcoming classes. Okay, so and then next additive identity. So these both topics revise properly and understand properly. Okay children, hope you all understood it. Thank you. Please share, like and subscribe, and send me in my comment section whichever topic is required for you, so that within no time I will be sending you back the videos which are required for you. Thank you for watching.